Let's go to question 2. Nadia designs a waste paper bin made in the shape of an open cylinder with a volume of 8,000 centimeter cubed. Nadia decides to make the radius R of the bin 5 centimeters. Calculate the area of the base of waste paper bin. The base area is the area of this circle. We got to use pi r squared. So we get pi times 5 squared equals 78.5 centimeter squared. 2. The height h of Nadia's waste paper bin. We know the volume of this cylinder is 8,000 centimeter cubed. Let's find the volume of the cylinder in the booklet. Here is the formula. V equals pi r squared times h. Do the substitution. 8,000 equals pi times 5 squared times h. Let's go to equation solver. Type in the equation. Control menu. Enter, enter, enter. H equals 102. A3. The total external surface area of the waste paper bin. Here is the formula given in the booklet. Area of the curved surface of a cylinder. Since this cylinder is open, so we only need to add the bottom surface area to this curved surface area of this cylinder. So total area equals 2 pi r h plus pi r squared. Do the substitution. Total area equals 3,282.96 centimeter squared, or 3 sig figs 3280 centimeter squared. B. State whether Nadia's design is practical. Give a reason. The height is more than 1 meter. It's too high for a waste paper bin, so not practical. Reason is the height of the bin is too high. C. Marion also designed a cylinder waste paper bin with a volume of 8,000 centimeter cubed. She decides to fix the radius of its base so that the total external surface area of the bin is minimized. Let the radius of the base of Marion's waste paper bin be r, and let its height be h. Write down an equation in h and r using the given volume of the bin. We got to use this formula. V equals pi r squared h. V volume is 8,000 equals pi r squared h. Let's go to D. Show that the total external surface area A of the bin is this. We will use this formula and also the bottom area of the bin to figure out the total surface area. A equals 2 pi RH plus pi r squared. Let's check this equation. A equals pi r squared plus 16,000 over r. No h. We need to use r to substitute for this h. This is the formula we got to use to work out h. Both sides divided by pi r squared. So we get h equals 8,000 over pi r squared. Therefore, total surface area A equals 2 pi r times 8,000 over pi r squared plus pi r squared. Simplify. We got 2 times 8,000 is 16,000 over r plus pi r squared. Let's go to E. Write down dA dr. We know A equals 16,000 over r plus pi r squared. Here is the formula for derivative. We know x prime equals 1, c prime equals 0, x to the negative first power prime. Try to remember. X to the negative second power prime. Since we have r as a denominator, first step, we need to change this into single power form. 16,000 times r to the negative first power plus pi r squared. Therefore, dA dr equals d dr of 16,000 r to the negative first power plus pi r squared. So we get 16,000 is the coefficient. So we bring it down. R to the negative first power, we got to use this formula, which is negative 1 over r squared plus pi times r squared prime equals 2r. Then simplify. Negative 16,000 over r squared plus 2 pi r. Let's go to F. Find the value of r that minimize the total external surface area of the waste paper bin. We will set up dA dr equals 0, which means negative 16,000 over r squared plus 2 pi r equals 0. Let's go to equation solver. We got 13.7 is the solution. By solver, r equals 13.7. Calculate the value of h corresponding to this value of r. We got to go back to this formula. To figure out this h equals 13.6 centimeters. You could say the height and the radian almost the same. G. Determine whether Marion's design is an improvement upon Nadine's. Give a reason. Marion's design is an improvement because the external surface area is minimized. Or you could say the height is more practical and so on. I will use total external area is minimized as the reason.